All right, here is the solution here. I was mistaken because we're given the Mappings dictionary. The keys are the alphabet and the value is the numbers. So I had it the other way around, but I corrected it now. But we still need it the other way around. We need these to be the keys instead of these, and these to be the values. So we have to invert this mappings dictionary like we had it before. So we're just gonna use a Python we're gonna just invert it just using Python functionality. So here I created a function here which is called the recursive function. You throw in there the number, and what this recursive function does is first it figures out how many digits the number has, and once it finds out how many digits the number has, if the number of digits is greater than 2, we're gonna go into this if conditional. And what will happen is we'll capture the first digit under this variable by doing a just a little bit of mathematical manipulation here, by dividing the number by like 100 and then dividing it and then capturing. Basically we're just doing mathematical manipulation to capture the first digit of that number, and here we're capturing the second digit. The rest of it, rest 1, will be thrown into the recursive call so it can be processed here, and then there'll be a summation. I'll explain what the summation is at the end of the calls down below. So it'll take I want to first go through this scenario where there's more than 2 digits. Yeah, more than 2 digits. So anyways, the rest of it will get processed here, so we got to remember that later. This number weighs starts out at 0, and at the end of the calculation, if it processes all the digits and all the digits are valid, a 1 will be returned. This function here will return the number 1. If not, it'll return the number 0, and all those numbers will get summed up here, and at the end of all the calls, when all the recursion is done, we will get how many different ways that number 5 basically that we got for that one message. So here we're checking that if it's within the alphabetical range. So we have to have either it has to be greater than 0 and less than 27, because the alphabet has 26 numbers. So 0 is not valid, 27 is not valid, because 1 is A and Z is 26. So once that happens, that means this is a valid 2-digit number, and this is the remaining numbers when you take away 2 digits. Here's the remaining numbers when you, so this is that 2-path binary tree recursive call that I was talking about. One of them we stripped the first digit off, and here we stripped the two digits off, and then we're processing the rest of it. And these 2 paths, each one will return a sum, and then later those sums will get summed up themselves too. Here's where we're returning that number. Okay, and here we're returning negative 1000, and I did this so this can be an indicator of that something is wrong, that an error has occurred, because it should never return a negative number. So if we get a negative number, we know that something went wrong. All right. Now here is the conditional when it's equal to two digits. So here's more than 2 digits. Now we're looking at 2 digits. If it is 2 digits, we basically do the same thing again. The only difference is we're not doing a recursive call for the 2. When the 2 numbers, we're not doing a recursive call. This line is missing from this here. Again, we're returning -1000. Something goes wrong. Else, and this else will only happen if there's only one digit left. If there's one digit left, we have to make sure that that digit is between 1 and 9. Probably can get rid of this because it will never, one digit's never greater than 9, I guess. So this is kind of like overkill, but I'll just have it there. And if that number is between 0 and 9, we're going to return a 1 because we just got done with that path and we found a word and we have no more digits left, since we only had one digit left and we already processed it. Here is we're gonna see, we put that number that we solved on the board up here, and we'll see if it returns 5, because there were 5 ways to look at this. All right, let me see. Let me run this. So we did get 5. I'm gonna throw a couple of other numbers in there. Let's put in there 44. So this should be 2 ways because there's no 44th letter in the alphabet. Why is it 1 way? That doesn't make sense. 4 and a 4. Yeah, that's a 1 way. Sorry, not 2 ways. 2 ways would be if there's a 44th letter and a 4. So right now, the only way it can be looked at is DD, and that's the only way. Each 4 has to be looked at individually, and that's the only 1 way. There's no 2 ways. I meant that you can look at it as 2 separate letters, 4 and 4, D and D. All right, let's see. I'll put another one here. I'll put a 0, 0 in there. It should return negative something. Or none, okay. Yep. And then let me put in here like 1, 2, 2, 1, 3, 1, 2. So this message can be decoded into 16 different ways. Or I'll say 99999. This should be 1 way, because you can look at it as the 9th letter, the 9th letter, the 9th letter, the 9th letter, the 9th letter. That's the only way. So yep, it's only 1 way. Okay. So that's it for this tutorial. This is my solution here, and it's basically one recursive function that takes care of the whole issue.